simplifying multiple expressions using Casio FX-570ES or 991ES Plus 2nd edition. In this example, we will design a reinforced concrete rectangular beam for flexure. So the beam has a width of 300 millimeters and an effective depth of 535 millimeters, and it carries a maximum factored moment of 250 kilonewton meters. The material properties are Fc prime equals 20.7 megapascals and Fy equals to 415 megapascals. We will use the NSCP 2015 provisions and the strength reduction factor of P equals to 0.9. Now, to design this beam for flexure, the steps are as follows. First, we will calculate the resistance ratio Rn, which is equal to mu divided by VBD squared. And then after that, we will also calculate the value of m, which is denoted by Fy over 0.85 Fc prime. And then using the values of Rn and m, we will plug it into the value or the formula for the steel ratio ρ, which is given by the formula of 1 over m times 1 minus square root of 1 minus 2m Rn over F1. For the purposes of this video, we will assume that the minimum values have been met. So in this case, it's already met. And then finally, after calculating the steel ratio ρ, we will now plug it into the formula for the value of AS, which is ρ BDW, which gives us the desired tension area for this beam, which is our final answer. Now notice that the formula list is separated by these colon symbols. So in the Casio calculator, we will call that as the colon operator, which is the focus of this video. Now first, so let's run our calculator. Let's first input this first expression. So we have A as the variable for Rn, and then D as the variable for mu, and then for the other variables P, B, D squared, we will input them as exactly as they are given. So let's have A, which is alpha, and then A, so the minus sign, so that gives us A. And then for the equal sign, we will input alpha, and then calc, which is the equal sign. And then for this expression, we have D, alpha, and then sine key to get D, and then divided by this expression on the denominator, so we have 0.9. Let's put parentheses just to make sure. 0.9 times 300 for BW, and then for D, we have 535 squared. So we have now the first expression. Next, for the colon symbol, which is in this formula, we need to press alpha and then the integral key right here. You will get the colon operator. Okay? Next, let's input the second formula. So m is designated by the variable b for this problem. So we have alpha, and then the degree symbol, which is this one, b, and then equals, so again, alpha, and then calc. And then for the fraction, 415 over 0.85 times 20.7, so that's Fy, which is 415, divided by 0.85, 85 times Fc prime, which is 20.7, so 20.7, and then we have now the second formula. For the third formula, which is the steel ratio ρ, we will designate variable C for the steel ratio, and then since the formula contains m and Rn, which is assigned to variables B and A respectively, so we will also include B and A in the formula. So again, we have the colon operator here, alpha, and then the integral key. So we have the colon operator. And then For the formula, we have alpha and then the hype key for the variable C, and then alpha and then calc for the equal sign, and then for the formula, we have 1 over B, alpha and then the degree symbol for B, times the parenthesis 1 minus square root of 1 minus 2BA, so 2 alpha and then degree symbol for B, and then alpha minus symbol for A, and then divided by 415, and then close parenthesis. We have now the third formula. And finally, we have the final operator for colon, alpha, and then the integral symbol. And then we can now input the fourth formula, so which is this one, rho dWd. In this case, since this is already the last formula and this is our desired answer, we do not need to assign an equal sign to this formula. So we can proceed right away with rho, which is assigned to C, alpha, and then hype key, which is C, and then for BW, so that is 300, and then for D, which is 535. Now, we are now complete in inputting the expression. So, next is, if we press calc, in this case, we will now be asked for the value of D, which is in the first formula. So, if we press calc, we will be asked for the value of D, which in this case is mu. So, we can assign 250 kilonewton meters. But since we need the answer to be in mm squared, we will convert this to Newton and mm. So, we need to multiply that by 10 raised to 6. So, we press 10 raised to 6. And then, after that, we can now press the equal sign. So, after that, the calculator will reveal the results for each of the formula in this list. The first expression reveals us the value of Rn. In this case, it's 3.23. And then, pressing equal sign one more time, you will get the value of B, which in this case is M, 23.59. And then, pressing equals one more time, you will get the value of C, which is the still ratio, or in this case, 8.68 times 10 to the minus 3. And then finally, pressing the last equal sign, you will get the expression or the value of the last expression, which is 1,393.87 millimeters squared. And that is our final answer to this problem. So as you can see, colon operator allows us to input expressions into a single line of input and then evaluate it one at a time in the calculator. And we can also assign values of expressions into variables and then use them in substitution to other expressions. So that's it for our video for today. I'm Engineer Jaydee and see you on the next video, mga Casio Nation.